Safety means safety of UAV as well as safety of civilians from UAV, and this is only possible when you ensure the collision-free movement of UAV. So why this importance? Why this collision avoidance is very important? Because it ensures safe operation of UAV. It avoids crashes, avoid risks for the people. Then cost of infrastructure as well as cost of UAV both matters here. Fine. Then again, it requires, it may be some under, it may be treated under law and order situation, and this is a kind of conflict. Fine. Then navigation is in close proximity to the obstacles so that we can have more efficient trajectory and paths. Fine. So what is a basic collision avoidance mechanism? So let's suppose if some UAV is moving and some obstacle is there, that may also move or that may be static. So what is happening in order to try, in order to have collision avoid situation, what should be there? So just assume that you are riding a bike and you have to take a turn. Fine. It turn may be due to the construction of the particular road or due to something that is coming from your front. So based on that, you have to take turns so that you can ensure your safety as well as your vehicle safety, and whatever work you are doing, that is also ongoing. Fine. So what you will do? So just try to think that you are sitting on the bike, you are at some higher speed, let's suppose 60, 70, and then if you have to take turn, then what you will do? If your speed is higher, then it requires larger distance to take turn. Hopefully you agree. If a speed is zero, then you can take 90-degree turn also. But if a speed is higher, then it requires larger distance, or you can say it requires sufficient distance or some safe margin is required to take safe turn. Fine. And again, the turning angle is also important, because if if you don't make a turn with some particular angle, then possibly you may collide or you may go out of the road. Fine. So using this analogy again, here you can apply the same analogy in context of UAV. So let's suppose if UAV is moving and some obstacle is there, let's suppose some fixed building is there. So UAV is moving with, let's suppose, consider two scenarios like 5 meter per second towards this building, and one is, let's suppose, 20 meter per second. So what will happen? If it moves with 5 meter per second, then it requires lesser margin distance to make the safe turn, and again it requires some particular angle where at which at least it should take turn of that particular angle so that it can avoid the collision. Fine. In the same way, what is happening here, there are two parameters. Based on this analogy, two parameters are being defined. First one, which is nothing but the safe distance, that is called turning radius. You can say this is a safe margin that is required for UAV turning. And then other one is semi apex angle, so it should take the turn at a particular angle so that it can have the safe trajectory. Fine. So each parameters whatsoever I am saying, like turning radius and semi apex angle, this will depend upon the velocity of UAV as well as velocity of obstacles. Fine. In some cases obstacle may be static or it may be moving. Fine. So if you go to the literature, then you will find that existing work do not consider the effect of wind. Fine. Because modeling of wind is very complex, it is random in nature, variation with altitude, direction as well as magnitude, both are important. So we have noted that the consideration of wind profile is very important. Now let me explain why this is important. So we have considered the data of two cities, let's suppose key based, that is located in Florida, and Medford, that is located in this Oregon. So you can see that the wind speed and wind direction, since wind is a kind of vector, so it has a speed as well as direction. So you can note that it's a speed as well as direction both varies significantly, it is not so static. So this is month wise variation. So you can see that even it can go up to 6 or 7 meter per second wind speed, whereas the typical UAV speed is around 5 to 15 meters. Typical, I am saying. So you can see that if UAV is moving with 5 to 15 meter per second and wind speed is around 7 8 meter per second, then you cannot ignore the effect of wind speed, because it is nothing but the relative velocity will come in the picture when you account the overall effective velocity of UAV. And again, the wind direction is also significantly varies. So you can see that it can vary from like 45 up to 170 degrees, something like that. Month wise variations are quite different. So how this direction will vary, because if wind speed and UAV both moves in the same direction, then you can have different overall effective velocity. If moves in some perfect opposite direction, then effective velocity is different, and if with some angle, then overall effective velocity will different. So that's why this wind speed and wind direction is very important. And you can see that the speed is very significantly higher, and this is almost comparable to the movement UAV, mobility of UAV. So that's why it is very important to consider. Fine. Now, what is the effect of wind on UAV movement? So let's suppose if you consider wind as wind velocity, and if you take its two components along x and y axis, so Vw is given, then x component Wx, you can take the projection along x and y, and then you can find the velocity along x and y axis. Fine. So now what is happening? Let's suppose if UAV is moving with a speed Vu in direction omega at a particular given altitude, then you can also find the x and y components of velocity of UAV. Fine. Now, how you will find the effective velocity of UAV? Effective velocity of UAV is nothing but the Vex, that is the velocity of UAV and this velocity of wind. So if you add them, then it will come in the picture the effective velocity. Fine. Now, just come to this system model. We have two parameters like semi-apex angle and this turning radius. So we have to model them. So what is happening here is that, let's suppose we have modeled this UAV as a sphere of, let's suppose, radius d1. So means you can say that at a sphere of radius d1 denotes the UAV, and you want safety of this. And then let's suppose some obstacle is also there, and that is of same distance d1. So you can change d1 also d1 d2, but for the convenience or for the sake of brevity, we have taken this d1 d1. So what is happening, whenever, let's suppose, the ideal scenario when there is no wind, then what will happen? Whatever is the movement direction of UAV, that will be same, because wind is not there. Fine. And if you consider the case when wind is there, then due to presence of wind, the effective velocity of UAV will change, and that is nothing but VE. So what is happening here, that let L naught and LU, you can see in the right side figure that L naught and LU be the locations of obstacles and UAV respectively. Fine. Then let's suppose semi-apex angle between L naught and L1. Two vectors are there. L naught is the vector which is connecting UAV to sensor node. Fine. And L1 is the vector which is connecting UAV uh, to the some surface of this sphere of this obstacle. Fine. And what is this L2? L2 is the direction of velocity, as direction of velocity when wind effect is there. Fine. So it will slightly change. So if you try to find the angle alpha naught, let's suppose when there is no wind, then the UAV can make turn at alpha naught angle, then it can safely cross this obstacle. Can you wait? Just wait for 1 minute. I will resume.
అంటే ఈ సర్క్యూట్ జీరో తీసుకుంటుంది, ఈ సర్క్యూట్ జీరో తీసుకుంటుంది. నేను ఇప్పుడు ఏం చేస్తున్నాను, ఆల్ ఆఫ్ సడన్ నేను ఏం చేస్తున్నానంటే ఐసీతో వన్ జనరేట్ చేస్తున్నాను. ఈ ఐసీతో వన్ జనరేట్ చేస్తాను. ఆ వన్ ఎక్కడికి వెళ్ళాలి? దిస్ వన్ హ్యాస్ టు బి కమింగ్ ఓవర్. అంటే ఈ పర్టికులర్ సర్క్యూట్ దగ్గర ఎంత వోల్టేజ్ డిఫరెన్స్ ఉండాలి? జీరో నుండి కాస్త వన్ అవ్వాలి. ఇక్కడ కూడా జీరో నుండి కాస్త వన్ అవ్వాలి. ఏది పాజిటివ్ అవుతుంది వన్? సో దీనికి కెపాసిటెన్స్ చాలా తక్కువ కాబట్టి కెపాసిటీ తక్కువ. అంటే కెపాసిటీ తక్కువ అనేసి అంటే అక్కడ ఏదో చేంజెస్ ఉన్నాయి అంటే he won't make it, won't, he will be accepting because like వీటికి అంత కెపాసిటీ లేదు అన్నట్టు. ఆ చేంజెస్ ని ఆపగలిగే కెపాసిటీ లేదు. he cannot stop the changes, so there will be change, it will be there reflected there, but he has a capacity because his capacity is very high, so he has a capacity to stop, hold that. So biggest value zero and he holds the zero itself, not to go to one. సో నా వీడు వన్ ని పంపించండి, వన్ ని రిసీవ్ చేసుకోగలుగుతున్నాడు. వీడికి ఏంటవుతుందంటే వన్ పంపించిన తర్వాత హీ విల్ టేక్ వెరీ లాంగ్ టైం టు గెట్ ద చేంజెస్. అంటే ఇమీడియట్ గా కొంతసేపు పోయిన తర్వాత గ్రాడ్యువల్లీ హీ విల్ టేక్ ద పార్ట్. సో బికాస్ సడన్లీ we cannot change it because this has more capacity. So suddenly it is not possible, right? It will take so long time to change that. అంటే ఇప్పుడు ఏం ప్రాబ్లం అవుతుంది? ఈ సర్క్యూట్ ప్రాబ్లం అవుతుంది. వన్ ఇస్ వన్ ఇది తీసుకుంటుంది స్పీడ్ ఎక్కువ.
Yeah, sorry for the interruption. Actually, some urgent work was there. So, so here we have obtained the semi-apex angle alpha naught in absence of wind. Means if wind is not there and UV makes a turn at alpha naught, then it can safely cross the obstacle. Fine. Now consider the case when wind is present. Then what will happen? Then it is not alpha naught. Then it has to make a turn with respect at corresponding to alpha angle. So alpha angle is the semi apex angle in presence of wind, and using dot product you can find it like this. Fine. So now there can be two possible cases. Let's suppose if alpha is greater than alpha naught, then UV makes a turn with angle at such that it can avoid the collision. So if alpha is greater than alpha naught, then it can avoid the collision. But if alpha is less than alpha naught, then collision is sure, means UAV leads to collision. Fine. Next, what is turning radius? So turning radius is obtained by this, where v is the effective velocity, g is the gravitational coefficient, and phi max is the maximum roll angle. So there can be two possible cases. If you consider r greater than d, so if turning radius is sufficiently higher than the distance between UAV and obstacle, then it will lead to collision. Fine. But if turning radius is less than d, means your distance between UAV and obstacle is very high, then basically it will avoid collision. Fine. So there are two cases. Now if you summarize them, so we have two parameters, semi apex angle, that we have obtained in case of there is no wind, that requires alpha naught. In case of wind it is alpha, and the turning radius, it depends upon v, and v is nothing but the effective velocity of UAV, which accounts velocity of UAV as well as velocity of wind. Fine. Now try to understand, there are different cases based on these two parameters. So as we discussed previously, if alpha is greater than alpha naught, then it will avoid collision, whereas if alpha is less than equal to alpha naught, this will lead to collision. Fine. If r is greater than d, fine, then this will lead to collision because there is no sufficient distance between UAV and obstacle so that it can make a safe turn, and if r is less than d, then it avoids collision. Fine. So to avoid collision, what is the key criteria? It should be turning radius should be d, means the distance between UAV and obstacle should be sufficiently higher than turning radius, and semi apex angle, that alpha should be greater than alpha naught. Fine. So based on these two basic requirements, now what we have to model this turning radius and alpha, and r and alpha both depend upon the effective velocity of UAV and effective velocity of UAV. This depends upon the velocity of wind profile, and finally wind profile is a random process, then also alpha, r and alpha are going to be random. So now, since wind is a random process, so it is very difficult to analyze, and capturing the variation of wind data through some well-known distribution is very difficult because it strongly depends upon the geographical location and rapidly changing weather conditions. Then wind has magnitude as well as direction, and modeling only the wind speed or only wind direction will not work. So now the question arises that R and alpha are random in nature, then how to model them? Because if we model R and alpha, then only we can model the collision avoidance mechanism. Fine. So for this purpose, we have used the bin data of last 4 years, uh, and that is downloaded from National Renewable Energy Laboratory. This is NREL, USA, and the resolution of data was 5 minutes. Fine. Then we have used discrete time Markov chain to model these two parameters, turning radius and semi-apex angle. Fine. Now, what is happening with this DTMC? DTMC will provide the steady state PMF for R and alpha, and we will use that particular PMF to find the collision avoidance probability. Fine. So this is one illustration of DTMC to find this semi-apex angle PMF. So let's suppose if alpha, that is what we are doing. We are taking the bin data of different samples. Then corresponding to each sample, we are finding the alpha. Fine. And then let's suppose for all the bin samples, we are finding the alpha, corresponding alpha. And if alpha lies in between alpha mean and alpha max with a step size of delta, then we can have ns number of steps in the discrete time Markov chain, and you can find ns as follows. Fine. Now, using the data of this alpha, you can find the transition probability of this Markov chain, which is nothing but the likelihood of transition from one state to other. Then you can find the steady state probabilities of this DTMC, and using this DTMC, you can find the probability of collision avoidance. So you can see that the CDF of turning radius and semi-apex angle are shown here, and you can see that this is not so easy, and it varies significantly. So semi-apex angle varies significantly in the range of, you can see, 0 to 42 degrees around. Fine. And it justifies the inclusion of bin data in the system, because if you don't consider the bin data, then you will not find any variation in this semi-apex angle. Then you can see that turning radius also varies in the range of up to 10 meter to 67 meters, and you can see that effect of wind is can't be ignored, and the turning radius is around 27 meter. Fine. So now we have to find the probability of collision avoidance. So to avoid collision, what should be there? Turning radius should be r should be less than d, and alpha should be greater than d. So since we have the PMF of r, means we have the PMF and CDF of r, we have the PMF and CDF of alpha. We know d because distance between this UAV and obstacle is given, and alpha naught can be also obtained using the distance and the size of the sphere, obstacle sphere. So we have all the parameters r and alpha, they are random, d and alpha naught are constant. So using this, you can find the probability of collision avoidance when both of these conditions, that is turning radius r should be less than d and semi-apex angle alpha should be greater than alpha. If both conditions met, then you can find the probability of collision avoidance. And finally, PCA is given as probability of r less than d into probability of r greater than alpha naught. Any of these two conditions violates, then it will lead to collision. Fine. So this is nothing but FRD CDF, and then this is 1 minus F alpha alpha naught. So we will use the steady state probabilities obtained from DTMC to find C probability of collision avoidance. So we have illustrated how to find this semi-apex angle using DTMC model. In the same way, you can find the distribution for this turning radius using DTMC. Fine. Now you can see the results. Then omega is the direction of UAV. Fine. So probability of collision avoidance varies significantly with the direction of UAV. Fine. So let's suppose here we have considered distance d between UAV and obstacle is 40 meter, and d1 means size of a sphere is 1 meter, and UAV is moving with 10 meter per second. Then with the data of three cities of USA, Medford, Denver, and Key West, we have obtained the probability of collision avoidance along this omega, means direction of UAV. You can see that this varies significantly, because as the direction of UAV changes, the effective velocity of UAV changes, and that significantly affect the probability of collision avoidance, because the alpha and R parameter will change accordingly and PCA will change. Fine. So that's why you can see that significant variation is there. Next, variation of PCA against D. D means the distance between obstacle and UAV. So you can see that as you keep increasing the distance, probability of collision avoidance increases, because as distance is larger, then UAV gets significant or sufficient safe margin, safe distance to make turn. Fine, but as distance is low, then it is very difficult to make safe turn. So you can see that if distance is 30 meter for the data of key based, then its probability of collision avoidance is only around 0.25. Fine, so this is very low. But if you increase the distance around, let's suppose 50 meter, then it is around 0.8. And if you go to significantly higher distance, then again it will increase. Now if you again, this was the same as previous one. If you go to the dimension of a sphere, so you can note that as this dimension of a sphere of UAV and obstacle this increases, then uh, the probability of collision avoidance changes significantly, because if the dimension of or radius of this sphere increases, then what will happen, it has to make larger angle, and that's why chances of collision is higher because the object is higher. So you can see that as d1 increases, this decreases, the probability of collision avoidance decreases significantly. Fine. Now next one is the variation against this speed of UAV, you can say. So you can see that as we are increasing the speed of UAV, probability of collision avoidance decreases significantly. Fine, because if with increase in the speed of UAV and the effect of wind both combines, and that have some significant effect. So you can see that in all the figures, the red one has more severe impact. Fine, so you can say that key based, the build profile of key based is very significant and severe, and it takes or you can, it is comparable to, you can say, UAV a speed. That's why it is affecting severely. Fine. So now here this is our concluding remarks. So we have proposed a framework to incorporate the effect of wind. Then we have modeled the probability of collision avoidance, fine, using the DTMC. And you can see that ignoring the effect of wind will lead to inaccurate system design, and which may have very severe consequence in the real life deployment. And UAV must be aware about its direction also, along with the speed, and also the build profile while making the turn to avoid the collision. And next, we want to optimize the UAV parameters so that we can further reduce the collision avoidance. We can further improve the collision avoidance probability. So this was all about my presentation. If you have any doubt, you can ask. Dr. Kalpana? Yes.
Participants, do you have any queries? Participants, you are having any doubts? Please ask questions.
Uh,
Last session is over. Please ask questions.
so if you are not means if you have any query, you can mail me also.
Yeah, please go to the comment section, sir. Suman Garu. Suman, sir.
Yes, yes. So
Please
now
go to the comment section, sir.
current section means. Okay.
Comment.
Okay, yeah, yeah, yeah. Just wait. So what effect will be the wind speed on energy consumption? Okay, fine. So see, energy consumption profile that strongly depends upon the UAV speed and payload. So for the timing, let's suppose payload is same, and due to presence of wind, its effective velocity is going to be changed. Then definitely, it will change accordingly also. So that's why this is very important. Not only the probability of collision avoidance, but also the energy consumption, which ultimately leads to the endurance, and these parameters will significantly change. So, and also let's suppose if you have to travel from 1 kilometer or 2 kilometer, let's suppose you be supposed to deliver some some goods or some consignment, then it is, if it is going against the wind, then its energy consumption may also change, then its delivery time may also change. Or let's suppose if it keep increasing its speed to overcome the wind, then also these profiles will change. So it has effect on the energy consumption, it has effect on the payload, it has effect on the quality of service and quality of experience of the user also, in terms of latency or delay of the service. So whatsoever you are saying is correct. So I have shared my mail ID. Let's suppose if you have any doubt or any query related to my work or this presentation, then feel free to mail me. Any other doubt? Either you can write or you can just ask. Dr. Kalpana,
Yes, sir.
I think they don't have any doubt, or they don't want to ask, or possibly they are enjoying their personal work. So by the way, just I would like to know the audience. They are students or they are faculty members, or means what their profile I
Yeah,
want to know.
everyone, sir. Students are there, researchers are there, faculty members are there.
Okay, okay, okay. Okay, means everything is there. A student and faculty members both
Yeah,
are.
every from every part they are there, sir.
Okay, 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 okay.
Yeah, anyway, you have given your mail ID, na, sir. They will ask any questions if you are having.
Okay, I don't have any issue.
Yeah, okay, sir. Thank you so much, sir. Thank you so much for
Ma'am,
coming.
actually, I have one doubt. Can I ask,
Yes,
Suman
yes,
sir?
please, please, please.
Uh, Very good afternoon, sir. My name is Durga Prasad, and I'm an NIT scholar in NIT Warangal. My research area is related to what you have been mentioning in this topic, sir. So,
Which one?
I've been trying to work on path planning and the impact of the wind on the direction of the path planning of the UAVs. Probably, I could look at the two dimensions which you are mentioning about, which would
Mhm.
impact on the path planning. One is the angle between the UAV and the wind
Yeah.
flow, sir.
Means obviously,
Just would like,
yeah.
sir, am I audible, right?
Yes, yes, please go
Yes.
ahead.
Probably would like to just try to further understand, like, because depends on the direction of wind along against or in the direction of UAV. Actually, I am trying to measure the cost impact as well as the time of travel kind.
Yeah, yeah.
Probably just want to find out what can be further enhanced that can help me to produce better results kind. Because first problem which I have taken was consideration of the wind effect on the total path planning as well as the energy consumption of the UAVs for travel from source to destination, sir.
Yes, yes. Whatsoever you are saying is perfectly right. As I mentioned while explaining to this Gayatri Sivani. So see,
Sir.
so what is your wind model currently? Means you are working for constant speed or for what?
Uh, Sir, actually, in the wind model, which we have, which I initially considered, this is my just first year of my journey, sir.
Hmm.
In this initial model, what we have, I have tried to assume was the total wind coefficient factor alpha, which will be the a parameter which will be subjected to both these velocities of UAV as well as the wind directions. As you mentioned in the previous slide, like a cos theta parameter.
हाँ हाँ
And
same question are हाँ हाँ.
I was just trying to measure like the alpha value will be impacted based on the both dimensions, VU
Yeah.
value as well as VW. And depends on the theta value, like for instance, the alpha value, higher the alpha value, the impact will be different kind.
See, whatever you are saying is correctly right, but still, hopefully you are also aware that wind profile is not constant. So first
Sir.
of all, you should incorporate randomness in the system. Either you can take some data or you can take some mathematical model. Fine.
Sir.
So just for the analysis, mathematical model is good enough, and then you can verify using some data set from either
Okay.
it is mostly available on ERA and you can find it on some Indian websites also, meteorological
Yes, sir.
department.
Yes, sir. Yes, sir.
As
Trying
you
to
estimate,
interpret
you
on.
can
Yes.
download the data, but the main challenge is that whatsoever data you are getting, that is of very low resolution. Like let's suppose whatever data I am using, this is of 5 minute resolution. Hopefully you agree.
Sir.
So
Sir.
if you talk in context of UAV mobility, 5 minute means 300 seconds. This is
Sir.
very large time, because let's suppose if drone is moving with 5 meter per second, then in 5 minutes it can move up to 1.5 kilometers. Fine. So
Yes, sir.
next, if you talk to me, one potential direction that we are also exploring, you should try to generate high resolution bin data. If you are working on some data set, or if you are working on your mathematical model, because the resolution should be up to, you can say, millisecond or second level, because slight change in wind direction also may lead to inaccurate system design. Or you can also use some machine learning techniques to, or interpolation or some other method to generate some synthetic data, high resolution synthetic data using low resolution data. So this can be also a key contribution, I think. Then next important thing is that rather than working on these things like R and alpha, that is good, but you should optimize other system parameters. Except build, we can optimize almost everything. Like you can find the what should be the optimal velocity and direction of UAV, because let's suppose if you are supposed to move your UAV with some particular omega direction, but shifting from omega slight to omega minus delta omega or omega plus delta omega, this may give you some sort of gain, let's suppose 5% or 10%, although there may be some disadvantages with also doing this. So you should analyze such kind of trade-offs also, means you have to optimize the UAV system parameters, because wind is not in our control, we can't do anything for that.
Noted, sir. Actually, what I have additionally added was wantedly to created some path points so
Huh.
that even there is a change in the direction because of the wind, they need to return back to
Yes.
the estimated points before it reaches to destination. Kinds.
Yes, that can be a safety for UAV also.
Okay, sir. Okay, sir. Thank you, sir.
One again, Gayatri Sivani, she is asking about how to accurately model the wind effect on UAVs, or any existing model that can be incorporated in channel modeling. Fine. So see, it depends upon the UAV. Like let's suppose if you go for the channel modeling, if you account the effect of wind, so its effective velocity may increase. Let's suppose 10 meter per second is the speed of UAV, and it is moving in the direction of wind having, let's suppose, a speed 5 or 10 meter per second. So let's suppose it is the effective velocity is 15 meter per second, or something higher or lower. So again, Doppler effect and other things you can model. Fine. Even the rate of change or the distance covered between a particular interval 0 to t, in both different cases, like in presence of wind and in absence of wind, both will change. So means simple, if you go with the free space path loss model, then again this will be also. But if you want to take account into this channel model, then again you should consider the velocity, and then you have to effect this smaller scale fading and Doppler effect.
Sir, good morning, sir.
Good morning.
Sir, myself, Dr. K. Nageshwar, sir. I am one
Yes
of
sir.
the coordinator of this entity.
Yes sir.
And myself and Kalpana Naidu madam is also working on this UAV communication, sir.
Yes, I have seen.
So in future we will. Can you have any collaboration work with you, sir? We will
Yes,
contact you through my
yes,
data.
B can have, means B can have some collaborative work. So I don't have any issue. B can go ahead with that.
Yes, sir. Thank you, sir. We will contact you,
Yes,
sir, through my.
yes. If we have some overlapping interest, then we should work.
Yes, sir. Yes, sir. Thank you, sir.
Thank you, sir. Yes, ma'am.
Participants, you are having any other questions?
I just want to say something to the students. Means this is my suggestion, or you can say my humble request. See, drone is the future of not only India, across the globe. Hopefully you are well aware about this Russia Ukraine situation, then Israel Gaza, and too many things. Even with recent conflict with Pakistan, we have also faced this kind of frequent usage of drones. Hopefully you all agree. So see, don't work only on this theoretical aspect. Try to go with some experimental related works. Let's suppose it may be some silly one. It is not too large, too big, too impact, too effective, but just try to start with some sort of experimental work. This is very important for our nation also, because in coming days we have to develop our own technology, and it is only possible when be academician, be a students, and be researchers start to take initiative in this field. So this is my just a suggestion, or you can say humble request, because see, we are not too far in this particular drone technology still. We are still doing good, but still others, our counterparts like China and USA, Israel, they are far ahead from us. So that's why if you go for some sort of, let's suppose start with some small experiment, proof of concept kind of thing related to your research, then you will have a different kind of insights, as I did during my PhD also. So no one wants to do experiment, this is also reality, but if you go for experiments, then you have a different insights. Your problem statement is very different from the literature or state of the art, so this is also helpful in publication.
Thank you so much. Thank you so much, sir.
Thank you, ma'am.
Participants, participants, you are having any questions? Okay, Suraj Suman, sir.
Thank you, sir. Thank you very much for your wonderful time.
Thank you, sir. Thank you, ma'am. Thank
Yeah,
you,
thank you so
everyone.
much, sir, for coming here. Thank you so much for coming here, sir.
Thanks.
Yeah, okay, sir. Okay, sir.
Okay, thank you.
Yeah, yeah. Let us have some sort of collaboration in the future, sir.
Yeah, definitely, why not.
Yeah, okay, sir. Okay,
Okay,
sir.
thanks.
Okay, sir. Yeah, participants, please meet at 2 o'clock again. Please come at 2 o'clock again.
సేవ్ అయి ఉన్నాను నాకు సేవ్ ఈసారి నోటిఫికేషన్ నాకు సేవ్ ఉన్నాను ఎందుకో పంపించుకోలేదు ఇంగ్లీష్లోని అందులో కాలేజీ కాలేజ్
మనం రన్ చేస్తాం, ఇక్కడ రన్ చేయాలి. ఇక్కడ రన్ చేసి ఏం చేస్తామంటే 1 to 10 ఇక్కడ రన్ చేస్తాం. ಅದಕ್ಕೆ ఇది 1 కలర్స్ ఈ 1